Hello viewers and welcome to my YouTube channel. Today we are going to provide a solution to x and y in this simple equation. But before then, as usual, don't forget to subscribe to my YouTube channel. That means if you are watching my video for the first time and you know that you haven't subscribed to my YouTube channel, kindly pause this video and also hit the notification bell so that anytime we upload video you will be notified. Thank you so much. So my people, let's provide a solution to x and y in this equation. The equation says 6 raised to the power of x plus 6 raised to the power of y is equals to 42. That is the first equation. And the second equation, that is equation 2, says 6 raised to the power of x plus 6 raised to the power of 3 minus x is equals to 42. We can see that the first equation is carrying two different variables, that is x and y, and the second equation is carrying only one variable, that is x. So in order to make it easier to solve this equation with ease, we need to handle equation 2 first because it is carrying only one unknown. So follow me, let's solve the equation together. 6 raised to the power of 3 minus x is guided by a particular principle, that is one of the principle in indices, which says that whenever I have a raised to the power of b minus c, it's the same thing as a raised to the power of b over a raised to the power of c. So going by this, I can rewrite 6 raised to the power of 3 minus x based on this format. That means I will have something like this: 6 raised to the power of x plus 6 raised to the power of 3 all over 6 raised to the power of x is equals to 42. That is going by this law. So I can see that I have 6 raised to the power of x. I have 6 raised to the power of x here. So I want to introduce another unknown that will represent 6 raised to the power of x, so that anywhere I see 6 raised to the power of x, I will represent it with that unknown so as to have a simple linear equation. So let a be equals to 6 raised to the power of x. Yes, so that anywhere I see 6 raised to the power of x here, I will put a. Let me divide the board. So going forward, I have a plus 6 raised to the power of 3 is 216 all over a is equals to 42. So I want to get rid of this fraction, this a, so I need to multiply each individual term here by a, so that I have a multiplying a plus a multiplying 216 over a is equals to 42 multiplying a, so that a times a is a squared plus this, and this will cancel this. I have 216 is equals to 42a. So let me make it a proper quadratic equation. So a squared minus 42a plus 216 is equals to 0, and we can see that this is purely quadratic. Let's solve this particular quadratic equation by factorization. So in factorization, we know that we must have to obtain the root of the quadratic equation. So now, in order to factorize this, we have to observe the coefficient of x a square. Since the coefficient of a square here is 1, that means I have a because a times a is a squared. This is positive and this is negative. Because here is positive, that means everything, because here is positive and here is negative, that means everything here will be negative. Then what are the two factors that when multiplied I will get 2 ones, and when added or subtracted between the two I will get 42? And I think it should be 6 and 36, because by the time I multiply 6 times 6, I'm getting this back, and minus 6 minus 36 is minus 42. So we can see that the minus 6 and minus 36 are the factors. So we remember the product rule, that when we have two numbers multiplying each other to be equal to 0, that means one of them must be equal to 0. So that means a minus 6 is equal to 0, or a minus 36 is equals to 0. That means a is now equals to 6 or a is now equals to 36. But remember that we were asked to find the values of x and not a. I introduced a in order to ease the solution at a particular point. So coming here, if a is equals to 6, at this important step, I let a to be equals to 6 raised to the power of x. So instead of a, I will now have 6 raised to the power of 1 is equals to 6 raised to the power of x. I have the two bases to be the same. So 1 is equals to x. That means x is now equals to 1. So, and if x is equals to 36, if a is equals to 36, still from this point 36 is now equals to 6 raised to the power of x. So this is 6 squared is equals to 6 raised to the power of x. I have the same basis, so x is now equals to 2. So we can see that x is now equals to 1 or x is now equals to 2. We can see that x is equals to 1 or 2. So having gotten the value of x, we can use the first equation because it is carrying two different variables to obtain the value or values of y. So let me clean here. So now from this equation, equation 1 says 6 raised to the power of x plus 6 raised to the power of y is equals to 42. So if x is equals to 1, that means 6 raised to the power of instead of x, I'll put 1 plus 6 raised to the power of y is equals to 42. That means 6 raised to the power of y is equals to 42 minus 6. That means by making y the subject of the formula. So 6 raised to the power of y is equals to 42 minus 6 is 36. So 6 raised to the power of y is equals to 6 squared. So having the same basis, we can equate them. So y is now equals to 2. So we can see that when x is equals to 1, y is equals to 2. And if x is equals to 2, that means going by this, 6 raised to the power of x plus 6 raised to the power of y is equals to 42. That means I'll have 6 squared plus 6 raised to the power of y is equals to 42. That means 36 plus 6 raised to the power of y is equals to 42. By making 6 raised to the power of y the subject of the formula, I'll have 42 minus 36. 6 raised to the power of y is equals to 6, which is raised to the power of 1, and the 2 will cancel. So y is now equals to 1. So in conclusion, we can see that x is now equals to 1 or 2 and y is now equals to 2 or 1. That means when x is equals to 1, y is equals to 2, and when x is equals to 2, y is equals to 1. And these are the possible values of x and y that will satisfy this equation. Someone may decide to plug in these respective values of x and y back to either equation 1 or 2 and see whether the equation will balance. Thank you so much for watching. Should in case you have any comment, or you observe an error, let's meet in the comment section. But don't forget to subscribe if you are a first time watcher.